Cool, cool. Okay. So first thing, we had a homework due yesterday. That was homework 7. Were there any questions about homework 7?
Do you mind going over that first couple questions with
For me.
probability?
Sure, sure. Yeah, it turns out that we're trying to do a little bit of a probability based on arrivals. So lambda is the average number of arrivals per unit time. So it says here we've got some sort of a exponential arrival time. And that exponential arrival time, this is what they call a Poisson distribution. And so I don't know if you had a chance to look at the videos on that, but what I did was I put together, let me see if I can bring this up, a computer networks video on Poisson arrivals. So I got a few videos here on that. And maybe, yeah, here it is, Bernoulli and Poisson theorem. So what happens with the Bernoulli choices, and this is like when you have a binary choice. So it could be heads or tails. That's a binary trial when you're flipping a coin. When you do that a lot, like when in the limit as the number of trials goes to infinity, it approximates a Poisson distribution. So the Poisson distribution is really the Bernoulli trials taken to the limit. And so what we do when we have a lot of arrivals where things might arrive or they might not arrive over a long period of time is we use a Poisson distribution to approximate things. And that has the advantage of giving us an analytic closed form solution to some of the basic questions. So in here we have this n equals lambda times t sort of thing, where n is the number of arrivals, lambda is the arrivals per second, arrivals per unit time, and t is the total amount of time. And this gives us a couple of simple results. One is called Little's theorem. The other is about Poisson parameters. I created these videos for you guys so that you could see this stuff. And what it eventually does is it gives us entry into what's known as a Markov process. Now, Markov process, if you've taken digital design with me, you'll remember finite state machines. These are Markov processes are just like finite state machines with a difference. And the difference is that there's probabilities on the transitions. So you go from one state to another state based on a probability of being, of leaving that state and arriving at the next state. That's what the MM1Qs is all about. So once you get into that, you're using what they call basic queuing theory. And so what I did was I created a series of videos that basically cover all of that stuff. And they go through the PowerPoint slides so that you guys can see that. And hopefully you had a chance to watch those videos. And I think I made reference to them in the Blackboard assignment. So when you go to computer networks and you look at homeworks and you see right here's the videos that give you that connection to Poisson's theorem. And so here at the top, you can see this is the probability of having an arrival versus the probability of not having an arrival and all the different n choose k type combinations. And you could see that in the limit, as things go to infinity, as n goes to infinity, you get an exponential distribution, and that is your Poisson distribution. This is called Poisson's theorem. And so we're assuming n is large and p is small, and then we can start to do approximations for things that effectively give us the analytic closed form solutions like this, this exponential thing, which is really, really convenient. And so we use that to get some of our results. And so that's where those numbers are coming from. Let me see if there's some more interesting. Yeah, here's one where I'm giving you, I think, sufficient detailed feedback. So here's the probability that K is greater than 5 arrivals, and that's equal to 1 minus the probability that K is less than or equal to 5 arrivals. And so here we are summing all of the probabilities for all the different Ks, 0 through 5, and that gives us this exponential distribution, which we can then plug in. And by the time we're done doing the plug and chug with all these numbers, I think, yeah, he says it's 3,000 bits. So he's got a bit error rate of 1 in 1,000. So that means that n times p is going to be 3. So now I got my exponent for the exponential in here, and I can plug in the summation from 0 through 5 on K. And that is something you might have to work out through, well, let's see, 3 to the, well, each one of the elements you can compute with the calculator, but to sum all 5 of these elements, you probably have to write it out, unless you write a computer program for it. I think it might be easier just to plug it in and do it, because the number is quite small. And so that's how you get that answer. Let's see. This is a very similar to the prior answer. And yeah, here's the 1 minus 0.916, and here is the actual 0.916. So this one is find the probability that there will be between 0 and 5 bad bits inclusive. And this one is find the probability that there will be more than 5 bits. So this is the inverse probability of that. And so this is the one minus this gives you that. And so these two questions are quite related. In fact, they're almost identical, except one is the 0 through 5 number versus the greater than 5 number. Let's see now. And here we are doing the number of errors between 3 and 5. So this is bit error rate probability with between 3 and 5 errors. Sometimes it happens with what you call error correcting codes, is the number of errors you can correct is quite small. And so it depends how much redundancy there is in the code. Let's see, what else? So then there's the, these are all the standard, I will call them Java questions. So we got a lot of that. Let's see, what else is there? Here's another probability question. This one's using Little's law. And so this is about, I guess it's a little contrived. Birds are coming in for a bird bath. They're arriving at a rate of 3 birds per minute. Here come the birds. They're customers. They have, and this just, I say this, okay, in all seriousness, they have exponentially distributed bath time. Okay, that doesn't make any sense to anybody, even me. But we use that because it's a convenience, right? From a mathematical point of view, having an exponential distribution means I have an analytic closed form solution, which allows me to make estimations. So then he says, how long must the bird wait in the queue? That is, wait to get their bath. So what we're modeling here is arrivals of customers who expect to have service. You could do this with a bank. You could say, well, customers come in with exponential distribution, 3 customers per minute, and then they have to wait at in a queue, right? Wait in line for a single queue, which could have multiple servers. I mean, there could be like a bunch of tellers, but you still just get one line. And so then the amount of, I guess you'd say, service time per customer is something that you might like to measure if you were doing an operations research thing for the bank. and you'd like to know how long a customer has to wait on average. So, I mean, if you told me it's 3 customers per minute and wait time is on average, I don't know, 1 minute per customer, how long would the customer have to wait? You'd want to, first of all, 10 seconds has to be converted. 10 seconds per word has to be converted into minutes. So this is the customers per second thing, 0.05 customers per second. We went everything into seconds instead of minutes. That's okay. So 0.05 customers per second, that's 3 birds per minute. 3 per minute equals, that's 3 per minute divided by 60 seconds per minute. So that's how you get that number. And then it says here, he's doing 0.1 customers per second, distributed bath time. So he takes 1 over 10 seconds per bird. You plug it in and you get yourself an answer. T equals waiting time in the system. Subtract 10 seconds for service to obtain queue waiting. So what do we got here? This is the intensity row, and that's lambda over mu. That's typically what they call it. That's traffic intensity. And mu is service time. Lambda is arrival time. And so this is a rate of service versus the rate of arrival. That's how they view these sorts of things. If you look at the video presenting the PowerPoints, you can get that sort of thing, I think. Are you guys looking at the videos? And I'm hoping you are. Anyways, let's see what else we got here. Any other questions about this homework?
That was all I had. Thank you.
Okay. Let's see now. I'm just going through it. So the Hamming code is an error correcting code. And it can be used for error detection, but often is not. Triple redundancy codes can be used for error correction or error detection. That's when you send the same bit 3 times. Let's see what else we got here. I think that's it. And the next thing that I got going, and here's what I would like to do. I think maybe what we'll do, because I'm a little bit worried about the midterm, is I would do an extra help session. There's a break coming up. This is coming up, I think it's called spring break. But I think I'd like to do an extra help session for everybody. Same time, same channel on, I believe the term is March 16th. You think you guys can make it on March 16th? Same time? Anybody having something going on?
What is March 16th? Is that a Thursday?
That's a Thursday. Yeah, it's the middle of our spring break, but it is a Thursday. And so what I'd like to do is I'd like to schedule a follow-up meeting just to make up for any issues that you guys might have on the midterm. So we'll do a midterm review, if that's all right, if people want it. Would people like to come on Thursday next week? If you don't want to come, it's all right. I get it.
I could try. I could try to come.
Okay.
I could try to come. It's just yeah. I would send out
Selena,
an email to the student.
are you available?
To the
Selena?
class.
Yeah, I should be available, but if it's also recorded, that would be super helpful as well.
All right, so I will do that. But I mean, if you guys have specific questions about the midterm, I will cover it. So I'm going to do a midterm review on the 16th of March, and I will see if anybody has any questions at that time, just in case you guys haven't had a chance to look at the midterm. What I will do now is I'm going to switch gears and move into the midterm because that's due on the 22nd. So that's about 2 weeks from now. So we're not assigning another homework next week, but we will assign the midterm. So the midterm should be available to you now. I think it's available. So let me just check. Here's the midterm. Let's edit the test options and make sure you have it. Yeah, it's due on the 22nd at 11:59 p.m., end of day. So I think having a review on the 16th is a good idea, just in case you guys need it. You can open the midterm and take as long as you like. You have 2 stabs at it. You get the highest grade of the 2 attempts. So if you've got any questions, you can ask them now, or you can ask them then. I'll give you an extra chance because I think I feel very distant from you people. You know, I don't like it. But that's okay. I mean, I get it. It's distance learning, and you can feel distant from people. But what I'd like to do, I think, is give you another chance to do a review. So I'm going to do a midterm review now, and then we'll do another one in a week from now. And so we'll go through it real quick right now, and let's just see what we got here. So this is 100 questions with 1 point per question. That's a lot of questions. So do not wait till the end or the last minute to do this, because you're going to have issues. You may not remember how to do base conversion. So I threw in these extra videos on base conversion so you can remember that, and maybe it'll come back to you. Or at least you can look at it again, because it's been a while. The test itself is a mashup. So what ends up happening is I'm grabbing questions from prior homework assignments and I'm throwing them in for you. So for example, like this little guy in here, you can probably find that in a homework assignment from before. But if you wanted to sort of just test to see how that would work, you might be able to just paste it in. And so here's 2's complement. And in fact, this is very similar to the question where you get to see the binary version of the underlying negative number. So this is a 1's complement, and we add 1, so that makes 2's complement, and that should output -4. And then you should be able to see all of that running from the course code. I don't know why it takes so long for this sort of thing to pop up. Maybe because it's recording, I don't know. Yeah. So here's how -4 is represented. And you can see we formed the 1's complement and then added 1, and we got the -4. And let's see if we can see what's going on here. This is an exclusive OR operation. So when you exclusive OR a number with itself, it becomes 0. So up arrow is exclusive OR. The bin, that's giving you a 32-bit binary output, so you can see what it looks like when the underlying binary is being shown. That's what get bin does. So he's formatting a binary string for you. And if there are leading spaces, they get replaced with a 0 so that you can see the leading 0. Because that's the way this binary string thing works. When there's leading zeros, it puts in spaces. But I don't sort of care for that. So I don't know if you remember 2's complement, but that's what they use for C, C++, Java, C#, internally. Here's the thing called the scanner, which is going to give you one integer at a time from the user, or in this case, from a string, and it will output the numbers. Let's see what else we got here. Oh, and this is using mod 2 operations. So when the number of elements read in is an even number, it will print it out. This is a reference to the model view controller design pattern. MVC. I don't know if you guys have been watching the videos. I'm hoping you have, and or you can read the book. It's on page 317 in Java for Programmers. So that's a design pattern. Did you guys have a chance to look at this midterm?
I have
Anybody?
not yet.
No? Okay.
I haven't looked at it either.
Yeah, if you have any specific questions about the midterm, I'd be very happy to address them. It looks like somebody has made an attempt. So somebody's working on this thing. Not sure who. It's an attempt is currently in progress. I don't know if it's you guys, but somebody's working on it. In any case, you've got 2 weeks to work on it. What I would suggest is that you take a look at it and then ask me any questions you want to about it, and I can answer them in front of the team. Let me see if I can get myself into student view. It says here, edit mode is on, edit mode off. So I think this is how it will look for you guys. Yeah. So this is the student mode. And so now if I click begin, now you get to go through the entire test as though you're a student. So DNS is the acronym for, anybody know?
I think it's A.
It's domain name service. DNS.
Fudge. God dang it.
So if you were to sort of, I don't know, bring up a hosts table, the hosts table would serve as a way to map the name into a number. You see, so if you wanted to ping the Mini from Neptune, ping Mini, you can see that he's mapped Mini into the 82 number, 192.168.1.82, so that I can use the term Mini and not have to use the term 192.168.1.82. So that's that. I mean, in some sense, one could say that putting in a static host table is not ideal unless you're like me and you statically allocate IP addresses to machines. I like it when my laser printer has a known IP address. So now if I ping LaserJet, he gets me into 192. If I wanted to, I could telnet into LaserJet. If telnet was available, apparently it's not. So if I'm on my Mini and I telnet into LaserJet, that is available. And so now I can look at the menu for my printer. And apparently there are many things that I can do, including setting a password, which I choose not to do because it's a printer and what the heck do I need a password for? And if I do set a password for my printer, I'll regret it because I'll forget it. So having an IP address is kind of important. You might like to ping Google. That gives me an IP address. That's a DNS service right there, domain name service. This is a top-level domain .com, and that's the subdomain Google. Other top-level domains might be .us, .tw, that sort of thing. So it's domain name service. Which of these are steps involved in distributed computation on the client? So read an instance of computable object, send an instance of a computable object, get an instance of the answer, process the answer. What do you think? You're going to go involve the distributed computation on the client. So the client is going to have to send an instance, get the instance back, process the answer. 2, 3, and 4 for sure. So that's a computation client. I got some of this stuff from the book, and also we've had a few online lectures on that. I hope you guys are watching some of the lectures. Here's the here's the web page for it. And so I got it all on these spreadsheets here. So if you go to the spreadsheet and then click on ECE 4320, that's the old course number. So this is your computer networks course. That probably ought to be renamed, I think. Let's just give this the name networks, just so you can see it. Let's see, what else do we have here? Did you guys have any troubles reading any of this stuff or watching it?
No.
Okay. Here's that thing about Hamming codes. If you wanted to look at that, I think you could copy link. Let's see if that plays okay. Paste and go. Yeah. So there's the Hamming codes lecture. Let's see if this plays okay.
Hi, everybody.
Yeah. So this is
Thought I
playing.
would, give you a brief rundown on
So you guys can get your lecture on Hamming codes if you want it. You probably haven't seen Hamming codes before. It's worthwhile taking a look at that stuff, I think, especially, because Hamming codes are kind of well understood and a lot of people know about them. So if you're getting into network programming, it's a reasonable thing to want to look at. If you wanted like a summary of Hamming codes, you could probably find a lot of it on Wikipedia. There's a whole bunch on Hamming codes. So there's that. And plus there's a ton of YouTube videos on Hamming codes if you don't like my Hamming code videos. But they'll kind of, this is a little bit high end as an explanation. It's not terrible though, because my generator matrices and my H matrices are probably close to theirs, although I think my orientation is vertical and theirs is horizontal. Other than that, it's pretty close. Let's see, Hamming code example. Yeah, I think I did the 7-4 Hamming code. That's the simplest one, really. So that's 4 bits of redundancy. They call parity bits. And then it's obtained by giving you a generator matrix, the parity bits, and that gives you a code word. So it's an interesting thing. I think you guys might like it. It's got the look and feel of something that you may not have seen before because it's a block code. And these block codes are done with matrix multiplies. But the matrix multiplies, you know, that it's a pretty simple example of linear algebra. I'll put it that way. So what's he up to here? He's showing you the data bits, and then he shows you what he's transmitting. So on the left is the plain text. On the right is the code text. And he shows you what he transmits based on an addition of some parity bit. It's a far more complex explanation than the one I gave, I think. So there's that. Let's take a look at some more of these questions. Anybody know what SMTP stands for? You can Google it if you want. You know, this stuff is not rocket science, believe me.
Isn't it, it's an, oh gosh, it's a mail something.
Simple
Yeah,
mail
mail
transfer
transfer.
protocol.
There you go.
So I use simple mail transfer protocol in my code for doing mail stuff. So if you look at the code, you should find a network package. And in my little network package, I've got a mail package. And I show you how to interface to Gmail so that you can send and receive mail. I guess, yeah, it looks like it might even work. But then you have to put in passwords and things like that to get it to work. And I don't know if I want to do that in the clear right now. It's prompting for, in other words, in order to be able to use the mail client, you need credentials. And my credentials are not hard coded into the code, because if I did that, it would, everybody could essentially go in and delete my mail or send mail in my name. But this all uses SMTP protocol. So that's a basic networking facility, I think. People should know how to do that. Let's see if I can get in here. Oh, here it is, content. You guys know about the OSI? Anybody want to take a
Open
stab?
system interconnect.
That's it. That's exactly right. You know how many layers the OSI reference model has?
7.
Yeah, there you go. So you guys are getting it. Routing is a service reserved for the transport layer, true or false? Uh-oh.
I think it's true. I'm gonna say true.
Yeah, it's the network layer. We all do
God
all
dang
the
it.
routing in the network layer. So IP, that's internet protocol, that's network layer. Or TCP, that's transmission control protocol, that's transport layer. So the different layers have different roles, and there are seven layers, just like the seven dwarfs. Layer that provides the user interface, which one's that?
Is it the application?
Yes, that's exactly right. I think you guys are gonna do fine with this. You'll have two chances. What I'll do is I'll ask, what do you suppose MIME stands for? No takers, huh? That's the multi-purpose internet mail extension. Used to be all the mail transfer agents could do was transfer text. And somebody had the bright idea of transferring attachments. So they took the attachments and they encoded them using UU encoding, that's base 64 encoding, and they transmitted them as attachments to the mail. But in order to know what the attachment process data type is, you put in a MIME header. So when you look at the RFC for the MIME headers, the original RFCs are extraordinarily old. It's like the dawn of the internet. So if you look at like RFC 822, it's 1982. It's the dawn of email. And so what they're doing is they're coming up with cute little text abbreviations for stuff that you might want to transmit, like IMG image. Let's see if they got JPEG in here. JPG, no. JPEG, no. PNG, no. So there is a, let's see, it would be something like this. IMG/JPG. That's a basic MIME type. And so here somebody's asking if it's the same as this other one. And now here's a listing of MIME types. And so these MIME types can be actually recognized by browsers. And so browsers will have plugins that allow you to decode these various MIME types. So you could have a MIME type for text. You could have a MIME type for RTF. So you might have something like text txt/RTF. That's a MIME type that might be good for rich text format from Microsoft. And so then you would say, I've got a Microsoft attachment here. And so this is a basic MIME type that you can use to transmit stuff across the network. There is text/RTF. So that's a Microsoft MIME type. You might have another one called audio/AU. And that does the AU format, which is a MULA format. There are all kinds of video formats. There's no end to the number of MIME types. In fact, you might be able to find a list of MIME types somewhere, list of MIME types. And here they are. So image/BMP. BMP is a bitmap application/Word because someone's encoding Word documents. So it may have a .doc suffix, it may not, but you can encode it so that people will know what it is when they decode. And so there's tons and tons of MIME types. In fact, you can invent your own. But it's a little bit difficult if you're going to invent your own, because then you got to get other people to write coders and decoders for it, unless you're going to write them yourself. So was a MIME type devised to enable message passing across the transport layer? The answer is yes. Mail transfer agents use the MIME type. That was sort of the bottom line on this. We're kind of jumping into the midterm here, aren't we? You guys want to take a little time on this and read the book?
Yeah, the book and go over the test. I don't think most of us have looked at it yet.
All right, you got busy with yesterday's homework. You got 2 weeks.
Yeah, we
Right.
also had a midterm yesterday for UMA. So
Oh.
yeah, we're all
McGee.
trying to catch up right now.
Oh, wow. Okay. Fair enough. Fair enough. I think what we'll do, and I think this will be helpful for the group. Let's rendezvous next week, same time, same channel. And we'll do a 5:30 session, and we'll do it in Zoom, and we're going to cover any questions that you might have. Any questions about this midterm? Does that sound fair to everybody?
Yeah, that sounds like a good plan.
Yes.
And Selena, are you okay with next week?
Yep. Mm-hmm.
Very good. All right, I'll send a message out to everybody. I think I'm going to keep today's session a little bit short because you guys haven't had a chance to look at this midterm yet. You know that it's not hard, but it's big, and there's a lot. And so I think you're going to want to go through it and maybe print it out. I don't know if you're going to want to print it. If you print this thing, it's going to take up a lot of pages. There's 100 questions. So I will answer as many questions as you like, but let's do it next week after you've had a chance to look at it. That'll give you some more time, and maybe give you a chance to kind of read the book and look at the lectures.
Cool, thank you.